The next page reviews sequences and series. So for 28, we want to find the first 5 terms of the sequence whose nth term is a sub n equals 1 minus 1 over n. So for this sequence, to find the first term, we plug 1 in for n. To find the second term, we plug in a 2. To find the third term, we plug in a 3, so on and so forth. So we know that our first term, a sub 1, is going to be 1 minus 1 over 1, which is 1 minus 1, which is 0. The second term will be 1 minus 1 over 2, so 1 minus 1/2, which is 1/2. The third term will be 1 minus 1 over 3, so 1 minus 1/3, which is 2/3. So hopefully that gives us enough information to go from there. So we can eliminate A and we can eliminate C. So it's either B or D, and we can find the fourth term. Oh, it eliminates D because 0 is our first term, so it would have to be B. And we could check a sub 4 would be 1 minus 1 over 4, which would be 3/4. So it looks like we got it, B. For 29, we want to find the 8th term of the arithmetic sequence where a sub 1 equals 5 and d equals 8. So it's very easy to find any term of a sequence as long as we have the rule for that sequence or the equation. So for our arithmetic sequence, we can use a sub n equals a sub 1 plus n minus 1 times d to come up with a rule for this sequence, and then we can plug in 8 to find the 8th term. So a sub n equals 5 plus n minus 1 times 8. So a sub n is going to be 5 plus 8n minus 8. So we know that the rule for this particular sequence is 8n minus 3. So to find our 8th term, we would just plug in 8 for n. So we have 8 times 8 minus 3, which would be 61. So C is our answer. For number 30, we want to find the 23rd term of the geometric sequence where a sub 1 equals negative 23 and r equals root 2. So for a geometric sequence, we want to use the rule a sub n equals a sub 1 times r to the n minus 1. So we have a sub n equals negative 23 times root 2 to the n minus 1. And if we want to find the 23rd term, we would raise it to the 23 minus 1 or the 22nd power. On the final, I will allow you to use a calculator for these problems. So you can just plug in negative 23 and root 2 times root 2 raised to the 22nd, and it would come out to D, negative 47,104. For 31, we want to find the sum of an infinite geometric series. So if we're finding the sum for an infinite geometric series, we want to know the sum formula. S sub n equals a sub 1 over 1 minus r. So we know that our first term is 1, and then our r is the rate that the numbers are increasing by. So it looks like everyone is being multiplied by 1/3. So we're going to subtract 1/3, which gives us 1 divided by 2/3, which if we multiply by the reciprocal is 3/2. So the answer is A. 32, we also want to evaluate a infinite geometric sum. We know that it's geometric by the way that the formula is written. We have an a sub 1, we have an r, and the r is being raised to an exponent. So we know we have a geometric sequence. So now we want to use the geometric sum formula in order to, the infinite geometric sum formula in order to sum this series. So we're going to use s sub infinity, and actually the first one should have also been s sub infinity, equals a sub 1 over 1 minus r. And in this case, to find a sub 1, we want to plug in 0 to find a sub 1 since this starts with 0. So if I plug 0 in, I get negative 2/3 to the 0, which is 1, and then 1 times 6 is 6. So we have 6 divided by 1, and we know our r is negative 2/3 since that's in the parentheses. So 1 minus negative 2/3. So that will be 6 over 1 plus 2/3, which is 6 over 5/3. And when we multiply by the reciprocal, we have 18/5 for our final answer. For number 33, we want to expand the binomial 2x plus y raised to the fourth. And to do this, we want to remember about Pascal's triangle because we'll need to use the fourth row of Pascal's triangle to get our coefficients. So to create Pascal's triangle, we start with a 1 and then 2 more 1s. And then you always start your row with a 1 and then add the 2 above it. So 1, the next will be 3, 1 plus 2 is 3, and then 3, and then 1. And for the fourth row, we have a 1, a 4, a 6, a 4, and a 1. So now we're ready to start expanding. So we first start with our first coefficient, which is a 1. And then I take my a value, which is 2x, and I raise him to the highest exponent, which is 4. And then I take my b value, which is y, and we raise him to the 0. Then we take our coefficient from Pascal's triangle, which is 4, take 2x, raise him to the third, and y to the first. Our exponents will be going down as the other ones are going up, and also your exponents in one term should always add up to 4, or whatever exponent we start out with. Then we have 6 times 2x squared, y squared, and we have 4 times 2x to the first, y to the third, and then our final term, which doesn't fit, we'll put it down here, is 1 times 2x to the 0, y to the fourth. So the last step is to simplify everybody. So for our first term, we have 2x to the fourth, and remember that the 4 will go to the 2 and the x. 2 to the fourth is 16, and x to the fourth, y to the 0 is 1, so we don't need that. For number 4, we have 2 cubed, and we need to take that 2 cubed and multiply him by 4, since that's the coefficient out in front. So 2 cubed is 8, and 8 times 4 is 32. So we have 32, x to the third, y to the first. Then we have 2 squared, which is 4, and 4 times 6 is 24. So we have 24x squared, y squared. And for our next term, we have 2 to the first, which is 2, and 2 times 4 is 8. So we have 8x to the first, y to the third. And then we have 2 to the 0, so that'll just be 1. So our final term will be y to the fourth.